Hello everyone, my name is Joseph. I am the co-founder and CEO of ProofBridge. ProofBridge, we are a peer-to-peer bridge between Stellar and Ethereum, where every trade is authorized by both parties' BLS signatures, and these trades are settled against a zero-knowledge proof of the counterparty's deposit on the alternating chain. Now, this video is the Tranche 1 delivery demo video for ProofBridge. And in tranche one, we promised three things. The first thing was to retire the pre-authorization middleman. And now every trade is authorized by the trading party's BLS signatures. And the second thing was to reduce the deposit proof generation time. Now this proof is the zero knowledge receipt that settles every cross-chain unlock. And the last one were other smart contract optimizations and flow. So the first thing I'm going to be showing you is the proof generation reduction, as that is like the easiest thing for us to see. And initially, it was within the range of 30 to 40 to 50, 60 seconds, but now we've been able to reduce it to less than 5 seconds. And we've also introduced guards to ensure that we don't go more than this. And yeah, so let's just go over to the app. Now, because of the fact that I wanted to show this, I integrated the new MMR generation into the old demo app. Now, this application does not contain the BLS registration. It's just for us to see that the proof generation time has reduced. So I'm going to go into my orders and yes. Now, usually when you want to generate the proof, you generate the proof when you're about to claim. So let's start to get that process started. So I'm going to need my timer for this. All right. So this is waiting for the wallet signature. I think it's up here. So this contains the information about the other data. So let me start the timer now and then confirm this. As you can see, the proof is generating. Initially, that generate proof time used to take about 30 to 40 seconds, but now we've been able to reduce it to below 5 seconds, and even that takes the whole transaction processing time to sub 30 seconds. And yes, the claim has been completed. So that's the verification that the MMR proof generation has now been reduced. Now, the next phase is the pre-auth part that has been retired. So initially, the backend layer was the one that was signing every action. It signs the actions, then you send it on chain, signs the action, you send it on chain, so that you can like authorize that, this action is true. But now with the introduction of BLS, the two traders can sign, and those signatures becomes the authorization for the transaction to be processed. And this is the flow. The two traders are now the authorization, bringing the powers back to the user. So now let me go to the main app, the current staging application, where this has been integrated in. All right. So this is the current application that includes the wiring for the BLS. So as you can see, for you to be able to process orders or create orders, you need to have your BLS keys registered or wired in. I had already registered, then I revoked them. So that flow is easy. So I'm going to register a key on Ethereum. So initially, the plan was to use KMS systems to authenticate or protect the user's BLS keys, but that exposes the extra security risk. The fact that if an exploit were to happen and the BLS keys were exposed, would literally be opening up the whole application to risk. And that was not a responsibility we thought we wanted to handle, so we changed the model we had initially tried to follow. So this new model is the self-derivation, where the users can derive their own BLS keys by using signatures and addition of other seeds. Now, there are a couple of seeds you can add. It's configurable to add your fingerprint and your fingerprint as a seed, your passkeys as a seed, your a range of different seeds to allow you to be able to generate your own unique BLS keys. The smart contract just enforces that any revoked key cannot be reused. So I'm going now. The only seed I'm using is just this signature method for creating my deriving a new BLS key. So let's confirm that transaction, and then we've created a key. Now we are going to register these keys on the BLS registry. So I'm going to actually sign two transactions, one for the Sequoia leg and one for the Ethereum Stellar leg. And that has been completed. You can just refresh and you see that the status updates to registered just based on confirmation. All right, wonderful. Now I can show you the contracts on chain, or the links will be provided in the submission. So moving on, let's now try to bridge an ad. Now, we can also create ads, as anybody can create ads, but before you can create a ad, you need to have a BLS key on the chain you want to act on. Now, I'm going to be acting on the Ethereum chain, meaning I have BLS key registered on Ethereum. Though the UI will prompt you that you do not have a BLS key registered on this chain, please register. That's if you're trying to do something on a chain that you have not registered a BLS key for, because that is your password, like your password or your authorization mechanism. So let's bridge an ad. Now I'm on Sepolia, so I'm going to be bridging from Sepolia to Stellar. Select the Autobot. Yeah, okay. So this is it. All right. I have 99250 here. How much do I have here? The Autobot. I have 999 and yeah, almost a million. Okay. All right. So I'm going to be bridging 500. Okay. That's the maximum. So it follows the same flow. First, you have to approve the wallet. All right, you approve the wallet. Then we wait for the confirmation. It takes a couple of seconds, and then you submit the order. And wait for confirmation. That has been submitted. You can now view our order. Now, because I'm interacting with a bot, it's quite going to be seamless. But if I'm interacting with other users, I'll need to wait for them to log the order and then co-sign against my order. So and now, yeah. So before we do this, let me just take you to the diagram. Yes. So as you can see now, okay. So the first user, which is the maker, has already co-signed on his end. So all I just need to do now is to co-sign on my end, which is what I'm going to do now. Now, co-sign, I'm going to use the generated BLS key, and now this generated BLS key is not stored anywhere. The only thing is that the public key hash has been stored on chain, so we need to just regenerate it again. That's why it's like it has to be derivable. So in this way, any device you are working on, all you just need to do is to make sure you have the wallet. Once you have the wallet, you can continue your transactions anyway. You are not locked in. And then yes, that is all. And you can see this flow is a bit more different to the first app flow. and just wait a couple of seconds, and then the order is completed. I can check my balance to see that I was credited. Let's see. Yes, voila, I was credited. So explain what happens behind the scene. Uh, let's go here. So behind the scene, we moved most due to the fact that now proving happens in sub-seconds. We moved everything back to the background. So the the workers then they take the two signatures from the maker and from the bridger, they aggregate them and combine them into one. They send it into the prover. The prover generates the deposit proof. That happens in seconds, and then they are both published on chain. And the area now it owes no fund, it grants no approvals. Any honest party could run the same code. All you just need to do, take the two signatures, combine them, generate the proof, and then you publish on chain, and your money is in your wallet. So you're not locked by any pre-auth or any other requirements. So so that's basically it for the BLS signatures. Um, Yes. Now, the other deliverable, the BLS auth circuit. Now, we deliver this as specified with the 4 case test pack and the sub 30 seconds proving reference on the reference machine. But the issue we had with this was that it was easier and cheaper to use native BLS. So we switched our approach and we moved to using the native on-chain BLS. So using Ethereum precompiles on Sepolia and then the Soroban newly added host functions, we're able to verify the aggregate at a fraction of the gas, and the circuit remains as a proven fallback. The links will be added in the submission document. And our scorecard, all the success criteria were met. The period part retired on both chains. The BLS flow on the Stellar to Sepolia end-to-end. The proof generation sub 30 seconds, and then the CI guards, the Soroban pairing check shown on 10, also the demo, which is this video, and integration test. Now, for the integration test, let me show you that. Yes, so we have a couple of integration tests that are running constantly to ensure we there is no regression in any of our code. The first one, we have the backend relayer. Now this integrates. Now in this current state, our backend acts like an orchestrator, so it doesn't do anything. It's just the job is just to organize the transactions and their flow. So in the test, we add different life cycles for the ads, which this is now from the generation of the data from the backend, publishing it to a live contract, which were deployed earlier in the test flow. We also have a unique cross-chain E2E test that allows any other person that does not want to go through our relayer can also come and integrate directly with the contract without having to worry about any issues you get. So that also works. Those are the two end-to-end tests that we have. We also have a circuit CI to make sure that we are not regressing by the time we make updates or we make adjustments. We are below the gate count and the tripwire. So there's a gate count tripwire that ensures that okay, the sub-proofing seconds that we've achieved, we don't go and break that anymore. So those are the CIs that are available um, for the bridge application. Okay. Yes. So um, every deliverable is one link away. The BLS execute, the key registries, the proof benchmark, and the CI guards. The live app, which is on status now. Okay, this is the link to the old app. The live app will also be provided in the document, the stateless relayers, and the docs, and also the demo trades. We've completed over on this account. We've completed over 11 trades, and on other testing accounts by the team. So these are all on chain. I can show you that yes, this is okay. Let's see this. Okay, now most of the transactions were in this direction. So as you can see, very lot of transactions have been done to test and see that this is working. Thank you very much. Uh, thanks for watching.